The word nebula is of a Latin origin, and it's the word cloud. It originally referred to a mist, a vapor, a fog, a smoke. When you see images of these things, you'll kind of see that like wispy, sometimes tendril-like shape about them. These faint, fuzzy objects through early telescopes, sometimes they were resolved into groups of individual stars called star clusters. Into the 20th century, astronomers still referred to galaxies as nebulae before their true nature was discovered as these, immense gravitationally bound star systems. What happened was everything in the night sky, early astronomers and philosophers thought it all belonged to our Milky Way galaxy, barely even knowing what the Milky Way galaxy was. It's so hard to determine the third spatial dimension. When we look up at the night sky, this is what we actually call the celestial sphere. It's the fact that everything appears to be on the same plane. This is where constellations come from. So the objects in constellations aren't necessarily anywhere near each other in that third depth dimension, but they appear to be because they're so far away that we lose sight of that third dimension. With our current sophisticated telescopes, we're able to distinguish more detail in the nebulae and how that they interact with light differently due to their composition and their structure and where they're located in the sky. So I'm going to, on my Slooh account, so if you want to know how I got to my pictures, if you go to telescopes, my pictures, that's how I got here. I have a lot, so I'm going to filter by nebulae. And here are all the missions that I've gone on to see these different clouds. And then if I click on photo roll, it'll just pull out for me the actual images. So missions, you can see I have more photos than I have missions. So that's for two reasons. One, a mission provides you multiple images. So if I have 3 images from one mission, I'll have 3 in my photo roll, but only 1 mission was taken. The other thing is if you take a live image during a live feed, if you snap an image with the camera button, then it'll go in your photo roll, but you didn't actually take that mission. So by scrolling my mouse over these things, I can see their names still. So if we're looking, we have a Reflection Nebula. The Orion Nebula is an Emission Nebula. We have the Rosette Nebula. This is one of my favorites. I love the dull pink of it. The Tarantula Nebula, which does come in color, but I thought that the black and white image was just really eerie. And we have the Horsehead Nebula, which is going to be really difficult for you to see. I'll bring it up when it's time to talk about it. But I'm just kind of showing through, here's a much better version of the Orion Nebula. Just checking that you can see what I think you're seeing. Here's a dud. So I'll delete this image. If you want to delete, just hover over the X and it'll go away. Sometimes if I have 2 of the same thing, I'll delete one if I just don't want it. No pressure. I just like to keep mine low. Here's another couple images of the Orion Nebula. Obviously, this one is the best one. So this one was taken with the Canary 1 telescope, our big half-meter. These were taken with Canary 2. So you can see how even though the same object in the night sky might be visible in multiple telescopes, there are telescopes that are optimized for objects in different ways. So if you're going to image the Orion Nebula, maybe you should use Canary 1. Anyway, so an emission nebula. Well, if you know what the word emission means, then it is exactly how it sounds. This cloud of gas and dust emits its own light because the gas that's contained within the cloud is so hot. So near this cloud of gas and dust is a bunch of stars. And these stars ionize the gas in the nebula to such high temperatures. There's an abundance of hydrogen gas sometimes. With the nebula is a particularly red or pink color. Look at the Orion Nebula for a great example. There's an abundance of hydrogen gas. These nebulae are occasionally referred to as stellar nurseries because the nearby stars that are forming the light that are heating up the gas in the Emission Nebula and causing it to emit light because it's so hot. This extra heating of the gas can cause star formation, and it's also presumed that these stars that are nearby were formed in the nebula itself. So this is what gives these the name of a stellar nursery, because we think it's an area where there's a high star formation rate. This star formation rate also helps to perpetuate the ionization of more gases contained in the nebula. So you figure these stars kind of formed near a cloud of gas and dust. They're heating this gas and dust, making it emit light, so we see the beautiful colors of the nebula. But then the heating causes other star formation to happen, and then this extra star formation is also reheating the cloud of gas and dust. So it's a nice perpetual cycle. Moving on, we have an absorption nebula, which is the exact opposite of an emission nebula. So this one has a much more common name called a dark nebula. My personal favorite, so if you're really into astrophotography, imaging, if you've talked to, maybe some other astronomers, you might hear them refer to it as a dark nebula, because that's exactly what it is. Similar to dark matter, it's something we can't see. We don't see the nebula itself. But I like the name Absorption Nebula because I think it's a nice contrast to the name Emission Nebula. If you know what emission is versus absorption, then you know that these two nebula exactly what they do, and they're opposite. So this is an abundance of dust that scatters and absorbs light at visible wavelengths. So the light that would be coming through it is actually being fully absorbed and scattered away by all of the immense amount of dust in this cloud. So we don't see the visible light because it's obscured these visible wavelengths. And it obscures the objects behind the nebula. So if you have, you might have heard of gravitational lensing, and this is on the way future syllabus schedule for this course, but when an object is behind another, the light comes through, and gravitational lensing, just since I've already mentioned the word, bends the light around the object in front of it. But for this case, the light is trying to come through the nebula, but it's all scattered away. When the sun's out during the day, but the sky is so cloudy. If you're in Northeast America, if you're between Connecticut and New Jersey, which is where I drove today, you'll not have seen the sun because the clouds were so crazy. I seriously drove it was like the tundra in Connecticut, and by the time I got to Jersey, it was a monsoon. It was so crazy, the weather. That's a total side note, and probably most people listening aren't from here, so you don't even care. But if the sky is super, super cloudy and you can't see the sun, that's what's happening here. The light is being completely scattered and absorbed, and you don't see the visible light. So these are undetectable to the naked eye, to optical telescopes. But in some instances, there might be an emission nebula behind an absorption nebula. And so around the absorption nebula, you can see the emission nebula, which then highlights the dark part, the part that you can't see. So we see kind of like an irregularly shaped patch of black in front of the emission background. In contrast to the hot emission nebulae, absorption nebulae are among the coldest places in the universe, ranging from roughly 15 to 100 Kelvin, which is colder than many of the coldest planets. So this image that I'm trying to show you right now is the Horsehead Nebula. This is an absorption nebula, and it's definitely not one of the best pictures I've got. Let me see if I turn on my brightness, if that helps. It's just the one that I happened to take with the telescope, so I challenge you to go out and take a better image and share it with me. But if you can see, there's kind of this reddish pink emission coming through, and then there's a dark patch right here. And now if you turn your head to the right sideways, you'll see that this is supposed to look like a horse head. I actually wonder if I have a better image somewhere on my computer that I might be able to post for you later in the discussion board chat. But these are really cool, and we did a lot of absorption nebula highlights in our Monsterlation show back in October around Halloween. That was super fun. So then the next type of nebula is a reflection nebula. So again, as it sounds, these are clouds of dust that are reflecting the light from nearby stars. So an emission nebula has nearby stars that are ionizing the gas to be really hot and make it emit its own light. Absorption nebula are absorbing and scattering away any of the nearby light, and so they appear dark. Reflection nebula reflect the light from nearby stars, and so generally blue Their color comes from the scattering of the light of the neighboring stars, because the blue light scatters much more efficiently than the redder wavelength light. So if you're familiar with the reason why our sky is blue, that's because our sun puts off white light, and when the light gets refracted in our atmosphere, it's kind of like a lens, the red light is much longer wavelengths and it's not scattered very efficiently, but the blue light with very short wavelengths gets scattered very efficiently, and so we see blue, which is why when the sun is setting and it's going through much more atmosphere than when it's overhead, the blue light is all scattered away and you're left with the long red wavelengths. So this is what's happening in a reflection nebula, is that generally the light that is most efficiently scattered is blue. These nebulae also indicate the presence of nearby star formation, because of course they need nearby stars in order for them to reflect the light to be called reflection nebula. So I'm going to go back, and I actually am not 100% positive if I have a reflection nebula or not, but let's take a look. I have one on the schedule for tonight, which is what I really wanted to show, but I'm not 100% sure if it's going to be online. So here we go, a reflection nebula. Perfect. And see, here is that beautiful blue color. And you can even see the stars where the light is reflecting them. And what's cool is that unlike an emission nebula, which just the whole gas is ionized and hot and emitting light, you can see where the brighter stars are, that the light is more reflected in these areas. The hotter stars, the bigger stars, more reflected light. Moving on, we have two more types. I hope I'm not rushing through this. I actually have, I'll share with you because I'm really excited. We have a info webinar at 8 with the NSF for that grant that we were awarded. So we have an info session tonight at 8 o'clock. And so I definitely have to be done by then tonight, but it's for a really good reason. So I hope you can all appreciate that as much as I do. So the next two types of nebulae that we're going to talk about are both results of stellar evolution. So I did a course on this a couple weeks ago. If you need a refresher or if you missed it, you can find it in our past live casts. But when a star undergoes the end of its lifetime, so basically it dies, there are two ways in which this can happen. So if it's a star about the mass of our sun or smaller, it's going to puff up into a red giant. It's going to shed its outer layers, and you're going to be left with a really hot, dense core called a white dwarf. When these outer layers of the puffy red giant shed off, they result in a planetary nebula. Now, planetary nebulae have nothing to do with planets, but they are the result of a star that is undergoing its end of lifetime. And the cloud of gas and dust that remains, which was the outer shell of the red giant, is shed away into space. Back around the 1700s, when these objects were discovered, I think it was William Herschel. I'd have to double check on the person for you. I'm sorry, I remembered the name earlier and now I'm blanking, of course, in the heat of the moment, right? But he looked up and he had just discovered Uranus, and it was this bluish green color, and he had seen these planetary nebulae that were also a bluish green color, and he thought to himself that that's what it looked like, and so he called it a planetary nebula, even though in fact it is not, as we know it, anything to do with planets. So I actually did, yes, it was William Herschel, so I'm glad I wasn't wrong. That would have been embarrassing. So he thought that this new object that he had found, this nebula, he thought that it resembled the gas giant Uranus in its blue-green tint, and so he called it a planetary nebula. Turns out that it's actually a cloud of gas and dust that is left over from when a star had died. And so the name, though, has persisted, even though it has nothing to do with planets. Astronomers are very notorious for not changing names when we know more about something. A good example of that is my research, which is in brown dwarfs. The term was coined back in 1975 when we knew it was a dim object, but we hadn't even discovered it yet. It was still just a theorized object. And so the color brown came from it being dim and hard to see, kind of like Dark Nebula. So then when we found them and they're not brown, we still call them brown dwarfs. So that's entertaining. And then the last type of nebula is actually a supernova remnant. So when the end of a star's life, I mentioned if it's a star about the size of our sun or smaller, it's going to end with a planetary nebula, which is the outer shell of the puffed up red giant that sheds off. When a star much more massive than the sun, about 8 times the mass of the sun or larger, hits the end of its lifetime, it erupts in a violent supernova explosion. So as opposed to that graceful puff up, shed your outer layer, this is a star that puffs up, collapses on itself, and then the collapse sends a huge shock wave out into space of gas and dust from the star. So a supernova remnant is what marks the end of the line for a massive star. When a massive star can no longer support its own weight, its own mass, all of the fusion in the core is used up, and it gets to start fusing iron, and it causes the core collapse. The star collapses, and then it results in this cataclysmic explosion. The event sends much of the remains of the star out into the interstellar medium, into space, that shock wave that billows out around the star. And as the cloud of material escapes away from the star, it can be seen after as a supernova remnant. And when we look at these, we see that they're not all homogeneous. They have a lot of what we call knots of gas in them. And so studying these denser regions of gas, we're able to pick apart the composition from the light curve that we get and know what the original star was made out of. Because, of course, the original star is no longer around for us to examine. I'm just going through my, I thought maybe I had an image of the Crab Nebula, which it appears I don't. Oh, Chile is online. Okay. So this mission is the Cone Nebula. This is an Emission Nebula. It's in the constellation Monoceros or Monoceros. I'm not actually sure how to pronounce that. My favorite is Monoceros. But if you had tuned into Helen Avery's Constellation Stories on Sunday, it was all about this constellation. So it's a really great time to look at this Emission Nebula. And it should be coming into color view soon. And then, but if you want to know what's next up, you can go to, well, you could go over here and it tells you what's up next. I guess I didn't have to go back to the page. But next I had up an embedded reflection nebula. So if you wanted to take an image of this, you would just press the snap camera button, and now you own this image. So this will tell you how much longer the mission is on for. This like green bar is telling you. And the next mission is at 7:55. So at 7:52, you can deduce that you have 3 minutes left. And so you would want to take an image a little bit closer to the end when we really get all of the resolution coming in. But I will look, since I have a few minutes. Oh, don't look at all my files on my computer. I'm going to pull aside to a photo folder that I have and see if I can't find you a really beautiful Crab Nebula image before I sign off. I think that would be appropriate. And I know I have one somewhere. You'll just have to be patient with me. I swear I have one somewhere. The reason I'm looking specifically for the Crab Nebula is because it's one of the most famous nebula, at least in my opinion. There are, here is actually a really great montage. This is by Slooh's head astronomer, Paul Cox. These are 6 images that he had used in a show one time that I have of his. But so obviously they're not all nebulae, and we've got a couple galaxies. Here's the Orion Nebula, but this one on the top left is the Crab Nebula. And so the Crab Nebula is a supernova remnant. It's in our Milky Way, and it's very, very famous. It's one of my favorites. You can find images of it all over. So if you want, I would suggest making a reservation of all the different types of nebulae that we have and comparing them and really looking at, you know, how a dark nebula is different from an emission nebula and a reflection nebula. But these are definitely 2 of my favorites, the Orion Nebula and the Crab Nebula. And in the Crab Nebula, you can see those knots of gas that I was talking about. So let me try to zoom in a little bit here. Nope. Oh, there we go. Awesome. I zoomed in on the wrong part, but that's okay. We're going to scroll up. Beautiful. We can see here these knots of gas that I'm talking about. And so when supernovae astronomers are studying the light from these remnants, they want to know what the star was made out of before it exploded. And somewhere in the core here is going to be the remnant of the star, the actual either black hole or neutron star that's left over, the hot dense core. But these knots of gas are what we study to get the composition of the original star, because it's much easier to get a nice light spectrum from these different denser regions of gas than it is from the more diffuse regions of gas. So last but not least, let me just refresh. We are now on the Reflection Nebula in the constellation Vela. This is called the Embedded Reflection Nebula. So I just randomly picked a couple tonight, no rhyme or reason, and the images will come in as the image just the mission just started. But this is embedded in what we call the Gum Nebula, which covers much of this part of the sky. And so you can see some more detail if you're interested in the object that I had picked. You can see like a little blurb over on the right-hand side. This is for any time that there's a mission going on. There should be a little bit extra over here about it. So that's all for tonight. Next week, we are going to go a little bit heavier, and we're going to talk about the cosmic microwave background. What is it? Why does it exist? And how do we know that it's there? So I hope tonight that you enjoyed looking at some pretty pictures. It was a nice light crash course. There wasn't a lot of graphics and diagrams that I had to get into, but I promise that we'll be back to those soon now that we move into deep space and start studying things like gravitational lensing and the CMB and dark matter. And I hope you'll join me next week. Have a great night. Clear skies.